Hello everyone, welcome to today's Yebo Tutor online session. So it's welcome to most of you that are joining us for the first time. My name is James and I know some we have met. We were at Umtata in the past week and we had a great time with most of you guys. So I hope you're gonna enjoy this session and more sessions that are outlined which are gonna follow in the coming few days. So our program runs every Monday, Wednesday, and Friday. So if you are on our WhatsApp group, you always get a notification whenever we'll be going live online. So for today, we are gonna start with static electricity. So I'm gonna just zoom into the question which is on the screen so that we can all be able to see. So with this question, this is a question on charges, and we have three small identical metal spheres, P, S, and T, on insulated stands. So that means they would not lose their charge to the ground, they don't discharge, or they are not earthed. They're insulated and have the charges shown. So initially, the charges the spheres are such that they're initially neutral, then they are charged to carry charges of negative 15 times 10 to the minus 9 coulombs. That's the unit of charge, the coulomb. And Q is an unknown charge on surface S, the metal sphere S. And metal sphere T has got a positive charge of magnitude 2 times 10 to the minus 9 coulombs. Now, the charged spheres are brought together so that all three spheres touch each other. At the same time and are then separated. So which means there is a distribution of charge according to this part. The spheres are made to get into contact. They're brought together such that they touch each other at the same time. Then they are separated, so they distribute the charge. The charge on each sphere after separation is negative 3 times 10 to the minus 9 coulombs. So we initially have P with a charge of negative 15 times 10 to the minus 9. We have Q, the charge is not given. Actually, the letter is S, sphere S, the charge is only Q. We don't know whether it's positive or negative. Then T has a charge of plus 2 times 10 to the negative 9 coulombs. So when we deal with these charges, the properties of charges are supposed to be at your fingertips. So they should be at your disposal so that you should know how these charges behave. So basically, we know the first thing, charge is quantized. So which means all these charges, the quantities were given here, are each a whole number multiple of the elementary charge, which is the electron charge. So they are n times the electron charge. So it means if you could use Q for the unknown charge, this Q should still be n times the electronic charge, where E is 1.6 times 10 to the negative 19 coulombs. So N is, it can be 0 if there are no charges, or 1, or 2, or 3, and so forth. So N is an integer multiple of the electronic charge. So if the charges you have each a charge of -3 times 10 to the -9. Okay, so I'm just gonna, so we've listed the charge on each sphere: P with a charge of -15, Q a charge of Q, or S with a charge of Q, and T with a charge of +2 times 10 to the -19. So the first thing there to note, or to try and recall, remember charge is quantized, and also remember charge is always conserved. So the second thing there is charge is conserved. So we have conservation of charge in as much as we have conservation of energy. So we also talk of conservation of charge. Charge can neither be created nor destroyed. So which means the total charge of the system should be constant. So the first question here is determine the value of charge Q. You need to find the value of Q. So knowing that charge is conserved, which means the total charge before redistribution or before contact should be equal to the total charge after contact. So using that property of conservation of charge, Q initial should be equal to Q final. And Q initial, we add the charge of P. So we have Q for P plus Q for Q plus Q for the other one, I think it's Q for S and Q for T. P, S, and T. This is initial, should be equal to Q for P final plus charge for P for S final plus the charge for T final after contact. So now we have the charge for P initially is -15. The charge for S, we don't know, is what we need to find. It's only given as Q, which is what we need to determine. The initial charge for T is +2 times 10 to the -19. And we know the final charges for each, they are equal and equivalent to -3 times 10 to the -9 coulombs. So you can you have an expression already. That means we can now substitute the values: -15 times 10 to the -19 coulombs plus Q plus 2 times 10 to the -19 coulombs. All this should be equal to -9 times 10 to the -9 coulombs. So now you make your Q the subject. That's -9 times 10 to the -9 plus 15 times 10 to the -9 minus 2 times 10 to the -19. So that will leave us with 15 minus 11, which is 4 times 10 to the -19 coulombs. This is the charge on T initially. On S, actually on S, which is basically the Q. Therefore, Q equals to 4 times 10 to the -19 coulombs. So we have solved this by using the fact that charge is conserved. So the total charge before contact is the same as the total charge after contact. So this is one way to look at this question. Okay, part 7.2. Let's see that one closely. It says draw the electric field pattern associated with the charged spheres S and T after they are separated and returned to their original positions. So both S and T now carry the same kind of charge. So what I was showing initially here is the field pattern between unlike charges. But for this question, we are required to represent the field pattern for like charges. So this is what I had before at the start of the session. These are unlike charges, positive and negative attract, and the field simply flows or has field lines flowing from positive towards the negative. And we indicate the shape of the field using the lines, and the arrows give us the direction of the field. That means the field is a vector field. So the electric field is a vector. So the field between the two spheres S and T, which have a charge of -3 each, should be such that the field lines, take note of these points, the field lines should never cross, the field lines never cross each other, and the field lines should touch the spheres. So they should start at a point where they're in contact with the sphere and end at a point in contact with the sphere. So they should not hang. We should not be seeing spaces there. They should be in contact with the surface of the sphere. And then you should use arrows to indicate the direction of the fields. So now we have two negative charges separated by distance. And one is S, the other one is T. And the field lines there, since they're equal, they should have the equal number of field lines. Don't forget, the more the field lines, the stronger the field. So we should be able to represent this very carefully. So we have a field looking something like this. So since these are negative charges, the field is converging into the charge. The negative charge is a sink, so the field, the arrows point towards the charges. So take note, the lines never cross, they should never cross, and you should also include arrows to show the direction of the field, and the lines should not hang before the surface of the sphere. So the lines should touch the spheres. So those are important things to note for such kind of questions. For such kind of questions. Now the next part says the spheres each with the new charge of -3 times 10 to the minus, oh, I was using -19. This is -9. Forgive me for that. That should be -9. That should be -9. It was careless on my part. So it's because I like the electronic charge a lot, but it's -9 like that. So our final answer should be of the same order. Q is 4 times 10 to the -9. Okay. So with that charge, the spheres with the new charge are placed at the points on the x and y axis as shown in the diagram, with sphere P at the origin. So that's the diagram. Sphere P is at the origin. Okay. And T along the x-axis and S along the y-axis. And the distances are given 0.1 meters, and P to T, the separation is 0.3 meters. Now the first part of the question simply says state Coulomb's law. So Coulomb's law, you should be able to recall that it is to do with the magnitude of the force exerted by one charge on another. So the magnitude of that force would definitely depend on the size of the charges, so the size or magnitude of each charge, and also inversely proportional to the distance of separation. So from Coulomb's law, we would know that we have F is equal to, that's where we get this equation, where if the charges Q1 and Q2 exert forces on each other, the magnitude of force is directly proportional to the product of the charges and inversely proportional to the square of their distance of separation. So that is all summarized by this expression where we find the electrostatic force between two charges. So the magnitude of the electrostatic force between 2 point charges is equal to the, or is directly proportional to the product, is directly proportional to the product of the two charges and inversely proportional to the square of their distance of separation. Okay. So that's Coulomb's law. Now we would use Coulomb's law to find the magnitude of the net electrostatic force acting on sphere P. So we have sphere P at the origin, and the force between the spheres is a repulsive force, meaning sphere P experiences a force to the left due to sphere T, and also experiences a force downwards due to sphere S. Okay, sorry about that. So the forces here are such that the force from T to P will give it a name, F1, and the force from S to P, or maybe let's just label according to FTP and FSP. So these are the two forces which are acting on P, and the resultant of these two forces will give us the net electrostatic force acting on P. So an expression for FTP will be K times QT QP over that distance in the x, let's call it x squared, and FSP is K QS QP, the product, over y squared. So now we need to substitute and find the value of each of these two forces. Sorry about that screen. So we have FTP and FSP. FTP is the force from T acting on P and is to the left. FSP is from S, sphere S, onto sphere P, and it's a downward force. So for FTP, we have 9 times 10 to the 9 for K. Then Q is 3 times 10 to the minus 9. Times another 3 times 10 to the minus 9. Over, we say this one is along the x, 0.3 meters squared. So the charges, we can include them there. They will give us still a positive. This is a repulsive force. So you can calculate that, tell us what you get. Mhm. 0.3 squared. So this is 9 times 10 to the negative 7 newtons for force. And for the second one, and this is to the left. And FSP will be 9 times 10 to the negative 9 times the same negative 3 times 10 to the negative 9 squared over 0.1 squared. And just replacing 0.1 there gives 8.1 times 10 to the negative 6 newtons downwards. So these are the two forces acting on P. And to find the net force, we need to use Pythagoras theorem. So if for those are the two forces, the net force is the resultant, which we obtain by drawing a parallelogram of vectors. So this is FR, resultant, to be FTP squared plus FSP squared. So the resultant force is equal to the root of FTP squared plus FSP squared, which is the root of 9 times 10 to the minus 7 squared plus 8.1 times 10 to the negative 6 all squared. This gives us 8.15 times 10 to the negative 6 newtons. And let's check what the question calculate the magnitude. So the question only requires the magnitude, and this will be okay without the direction. So FR is the net force or the resultant force. F net, you can call it F net, still okay. So the magnitude is only 8.15 times 10 to the minus 6 newtons. So it's important, you're given a diagram, the arrangement of the charges in this case, you should be able to know in which direction the forces between the charges act. In this case, the forces acting on P. And those forces will tell you how to get the resultant by simply looking at the way in which the forces are oriented. So we have a force to the left, which is the force from T on P, and the force downwards, which is the force from S onto P. And those two, by vector addition, will give us the net force by using Pythagoras theorem. So that should be quite easy. And in the next part, the net electric field at the origin due to charges S and T. So now what is needed is to know the relationship between force and electric field. The relationship between the force and the electric field. So know that electric field, we say this is a vector. It's also force, which is a vector per unit charge. Right? So our force, we got a value of 8.15 times 10 to the minus 6. So we have 8.15 times 10 to the minus 6 newtons. And the charge at the origin is negative 3 times 10 to the minus 9. So since we want also the magnitude, the sign there is not something that we need to consider much. So we can use the magnitude of the charge, which is 3 times 10 to the negative 9. Divided by 3 10 to the negative 9. So that gives us 2716.6. This is Newton per Coulomb. That's the magnitude of the electric field at the origin. So since it's magnitude, we can do this on the vector and we get just the magnitude. Okay, so one of the charged spheres P and T experienced a very small increase in mass after it was charged initially. Which sphere P or T experiences this very small increase in mass? So now we need to understand what happens during the charging process of the different spheres. So one sphere initially is charged to, we said, -15. When it is initially charged, it gains a charge of -15. And the other one, on initial charge, it has +2 times 10 to the -9 coulombs. So when we're charging these different materials, these two spheres, the accumulation of negative charges or the bringing in of excess electrons onto an initially neutral material results in an accumulation of negative charges that gives us a total of -15 times 10 to the -9. So this is a large number of electrons being brought into this onto this sphere to give it an overall negative charge. Then for the other sphere T, it accumulates or it ends up with a positive charge. So in giving it a positive charge here, it means electrons are removed. There's a deficiency. There's a deficiency of electrons. So in giving an object or the sphere positive charge, it means electrons have to be removed such that there remains a deficiency of electrons from an initially neutral body or object. So when electrons are added, it means a small mass should be added, and we can determine that small mass for case sphere P. So now we can determine that mass by first finding the number of electrons that are responsible for this charge, and we use now this expression. So let's see how many electrons that is, with Q equals to NE, Q being 15 times 10 to the -9 equals to N times 1.6 10 to the -19. So the number of electrons there we get by dividing by 1.6 10 to the -19 on both sides. Then we get N equals to 15, 10 to the minus 9 divided by 1.6, 10 to the minus 19. This is 9.375 times 10 to the 36 times 10 to the 10. That is times 10 to the 10. Electrons. So this is a number of electrons. So with this number of electrons, each electron has got a mass of, electron mass, you find this in the table, is 9.11 times 10 to the negative 31 kgs. So we multiply the mass of each electron, mass gained, equals to n times mass of each electron, which is 9.375 times 10 to the 10 times 9.11 times 10 to the negative 31 kgs. This gives us 8.54 times 10 to the negative 20 kgs. So this is the mass gained by sphere what? S, P, sphere P. So sphere P gains mass. By gaining electrons. So for that object which accumulates a positive charge, it is because it loses electrons. So the positive charge is due to a deficiency of electrons. Electrons are removed from the surface of the object. So which means in the other case whereby the sphere T after contact tends to have a charge of -3 times 10 to the -9, then which means electrons will move away from that part of the sphere. More electrons will be lost or will be redistributed from the sphere to the other spheres. That is from sphere T onto, actually more electrons will move from sphere P onto sphere T and sphere S. So the other two spheres here, sphere S and sphere T, after contact, they will gain more electrons such that they all get to a charge of -3 times 10 to the -9 coulombs. So after contact, both spheres also gain mass by gaining electrons. So that was for part 6.1 and 6.2. Okay, so we will end here for today. We'll continue on sections on electricity in our upcoming sessions on Yebo Tutor Live. So thank you guys for joining. We will be sending to you a link through which you can contact us, and you'll be able to chat with us via this same platform. So if you have an account, a YouTube account, please feel free to use our chat section to type in if you have any questions. And for those that can call via Zoom, we have a Zoom link that we can use for communication and real-time contact with you guys, so you can be able to interact with us live on Yebo Tutor. Otherwise, from me and everyone at the studio, all the best with your studies, and bye-bye for now.